increasing and decreasing functions, and relative extrema. Here's the definition of how to determine where a function is increasing, decreasing, or is constant. This one comes from our course textbook. A function f is increasing on an interval if, for any 2 points in the interval, a positive change in x results in a positive change in f of x. A function f is decreasing on an interval if, for any 2 points in the interval, a positive change in x results in a negative change in f of x. And a function f is constant on an interval if, for any 2 points in the interval, a positive change in x results in a zero change in f of x. The key phrase in each of these three definitions is this: a positive change in x. A positive change in x means that we are evaluating the graph of a function as we go from left to right. We will now evaluate the graphs of several functions. First, we have this quadratic function, f of x equals 1/8 x squared minus 1.5. As instructed in the definition, we evaluate for increasing, decreasing from left to right. The first thing we look for in a graph is critical numbers. A critical number is mainly found where the slope of a function changes from positive to negative or from negative to positive. The critical number is an x or input value where the slope of a function is 0 or is not defined. In this case, our critical number is x equals 0. In this case, at x equals 0, the slope of the function changes from negative to positive as input values change from negative to positive. This critical number separates the domain into two pieces, or as we call them in algebra language, intervals. We have the interval of less than 0 or from greater than negative infinity to 0. This portion of the graph representing this interval is here shaded in blue. And we also have the interval from 0 to less than infinity shaded in red. In the left interval, the function is decreasing in value, while in the interval on the right, the function value is increasing. In interval notation, we say that the function is decreasing on negative infinity to 0 and increasing on 0 to infinity. For this function, we also have a local minimum of negative 1.5 where x equals 0. This value of negative 1.5 can also be called a relative minimum or extrema. And since this value is the smallest value of the entire function, we can also call this an absolute or global minimum or extrema. Let's look at another function. This one is f of x equals 1 over x plus 3. For this function, the critical number is x equals negative 3 because that's where there is a break in continuity with a vertical asymptote of x equals negative 3. Going from left to right, the function value is decreasing on the interval from greater than negative infinity to less than negative 3. And the function is also decreasing on the interval from negative 3 to less than infinity. So in interval notation, we say that this function decreases on negative infinity to negative 3 and also decreases on negative 3 to infinity. The function is unbounded and has no extrema, that is, no minimums or maximums. Sometimes you'll hear people say no minima or maxima using the Latin plural. Let's evaluate this function as a cubic function with x to the third power. There are three separate intervals to evaluate for increasing and decreasing function values. Using calculus to differentiate the quadratic formula, the critical numbers are x equals 4 plus or minus the square root of 76 over 6. And decimalized, the critical numbers are x equals approximately negative 0.78630 and 2.11963. These values are the x-coordinates of the function where the function changes from increasing to decreasing and from decreasing to increasing. So we say that the function is increasing on negative infinity to negative 0.78630 and from 2.11963 to infinity, yet decreases from negative 0.78630 to 2.11963. Here are the coordinates for the local extrema of this function. We have a local maximum of approximately 8.21 rounded by the calculator to the nearest hundredths place. It's here where x equals about negative 0.786 that the function changes from increasing values to decreasing values. And we have a local minimum of about negative 4.06. This value input value about 2.12 is where the function changes from decreasing values to increasing values. Now let's evaluate this function. This is a constant function, the function f of x equals 3. The value of this function is unchanged from greater than negative infinity to less than infinity. Here we see the definition from the beginning, where there is zero change no matter which 2 points we compare in the function. So we say that the function is constant on the interval of greater than negative infinity to less than infinity. Let's look at this function, f of x equals ln x, or the natural log or natural logarithm of x. In evaluating this function for increasing and decreasing, it's obvious that the function is increasing over the entirety of its domain. It's a matter now of figuring out where the function starts. There is a vertical asymptote at x equals 0. Since the function is not defined at x equals 0, the function is increasing over its domain from greater than 0 to less than infinity. And this is the interval notation for this function's increasing. The function has no relative extrema, local, global minimums, or maximums. Let's review by looking at this graph. We'll evaluate for where the function is increasing, decreasing, and constant. This function is increasing on negative infinity to negative 7 and also on 2 to 6. The function is decreasing on negative 7 to 2. And the function is constant on 6 to infinity. These are called open intervals, using parentheses to designate them. There's a common mistake that many students have made is to say that the function is increasing from negative 4 to 6. But this is an incorrect interpretation, because where the function increases means the input values of the function, where the function values are increasing, decreasing, or constant, and not the output values. This has been Increasing and Decreasing Functions and Relative Extrema. Thanks for viewing. The function values are increasing, decreasing, or constant, and not the output values. This has been Increasing and Decreasing Functions and Relative Extrema. Thanks for viewing.